Now, let's try some voltage measurements. Measuring voltage is usually easier than measuring current. When you measure current, you must allow the current to flow through the ammeter. Voltage is analogous to electrical pressure. A voltmeter does not need to have current flowing through it. In fact, it is very bad if much current flows through a voltmeter. If current would flow through the voltmeter, it would adversely affect the voltage measurement. It would be like a tire pressure gauge that let the air out of your tire. Now, let's set up a circuit to do some voltage measurements on a series circuit. Starting with a simple circuit we built in part 1 with two 10K resistors in series, we would like to measure the voltage across one of the resistors. This is called the voltage drop across the resistor. It is not the same as the voltage from the battery. It will be less. Here you can see the test clips connected across the lower resistor to measure the voltage across that resistor. By the way, this meter has alligator clips connected to the test probe. Having a few alligator clips is a great help for making measurements. They are also handy for connecting other things like power supplies. Before you connect the meter to a live circuit, it is very important that you have the test probe leads connected to the correct jack or connector hole on the meter. Make sure that the red test lead is connected to the meter jack labeled volts V. This jack is also used for resistance, ohms measurements on most meters. Also, make sure that your meter mode selector switch is set to measure DC voltage. Since we are running on batteries or a power supply with low voltage, the 20-volt range is a good choice. Your meter will have a similar range. Be sure to double check your test lead connections to make sure they are connected to measure voltage and not current. If it is connected to the current jack and meter is set to measure current, you may blow the fuse or even damage the meter. Always double check your meter before making a measurement to make sure the leads are in the right jack and you have the setting correct. Now the meter is connected, go ahead and turn on the power and measure the voltage across the lower resistor. Be sure to make a note of your measurements. Pause this video while you try this. Try the same experiment with 1K ohm resistors. How does this voltage compare to the first experiment? Be sure to make a note of your measurements. Pause this video while you try this. Now let's try a voltage measurement on a circuit with a different kind of resistor, a photoresistor. There are some materials that change their resistance when light strikes them. A particularly useful material is cadmium sulfide. Cadmium sulfide, or CDS cells, rely on the material's ability to vary its resistance according to the amount of light striking the cell. For this reason, they are often called light-dependent resistors. The more light that strikes the cell, the lower resistance. Although not accurate, even a simple CDS cell can have a wide range of resistance from about 600 ohms in bright light to 1 or 2 mega ohms or million ohms in darkness. The cells are also capable of reacting to a wide range of wavelengths, including infrared, visible light, and ultraviolet. They are often found on street lights as automatic on-off switches. They were once even used in heat-seeking missiles to sense for targets. For this experiment, we will build this circuit. It consists of a photoresistor and a regular fixed resistor. We would like to measure the voltage across the fixed resistor. According to Ohm's law, in order for the current through a resistance to increase, the voltage across the resistance must increase as well. We can calculate the current that flows by dividing the voltage by the resistance. The formula is current equals voltage divided by resistance. So if we measure the voltage across a known resistance, we can indirectly measure the current. So if the resistance of the photoresistor changes, the current through the circuit will change as well, and the voltage across the fixed resistor will also change. Here is the circuit lab built on a Learning Lab prototype board. Notice how the voltmeter is connected across the 10K ohm resistor. Here is the voltage across the 10K ohm fixed resistor when no light is shining on the photoresistor. With no light striking it, the photoresistor has a high resistance, and so little current flows. When light strikes the photoresistor, there is a dramatic increase in the voltage across the 10K ohm fixed resistor, because the photoresistor allows more current to flow. the resistance of the photoresistor has decreased. Now try this yourself. In the next part, we will try some resistance measurements using our multimeter.